Assalamu alaikum. Welcome to another session of data structures and algorithms using C and C++. My name is Dr. Bilal Wajid, and today we're going to talk about double linked lists, specifically the delete function. So we've been discussing the double linked list from the lecture number 28, where we talked about very fundamentals like what are the global variables, and then we talked about how to make a create function in which really you don't have a double linked list. So how do you create one? And then in lecture 30, we talked about length. Here we're going to talk about the delete function that helps you delete individual nodes of a double linked list. Okay? As a prequel, you have these fundamental global variables. We have two of them. One of them is length, which holds and tracks the current length of the list. So whenever you add something, you add 1 to your current length. And whenever you delete something, you reduce it by 1. The other important global variable is this node by the name of start. So a start, whether it's a single or a double or a circular linked list, always points to the beginning of your list. Now, if there is no list, and that is the case when you're really starting, you're going to make sure that start is pointing to null. And hence you're going to say start has been assigned null. This is a definition of a node, and you can change it to have as many variables you want. We've just kept one for explanatory purposes. But what is quintessential in a double linked list is that for every node, there has to be a pointer pointing to the previous node, and there has to be a pointer pointing to the next node. Now, the delete has 5 cases. Okay, let's consider the first case. The first case is you want to delete something and you don't have a list. You can check that by 2 options. First, if the length is equal to 0, as has been shown here, or if start is equal to null. In both cases, you can just give a printout statement stating, sorry, the list is empty, so there's really nothing for us to delete. The second case is, or the second bunch of cases, is what happens when the list is not empty. Okay? Now, there are a number of cases here. Either you can try to delete the first node, in which case you're trying to delete 10, or you can delete a middle node, in which case, in this example, it's 20. Now, a middle node doesn't have to be really in the middle of a double linked list. It could be present anywhere. A middle node is defined as a node which has a node previous to it and it has a node next to it. Okay? Now, or you could delete something like a last node, in which case, you're trying to delete here 40. Okay. Now, 40 is the last node because, obviously there is this null that comes after it. Okay. And the fourth option is you're trying to delete something that's not there. So you're trying to delete 100, and you can see here, well, it's not even part of the list. So what do you do then? Okay. So delete function is a pretty complicated function, but our job is to make the complicated easy, okay? And hence this lecture on YouTube. Okay, so the first case is you're trying to delete the first node, in which let's say you have del10. Now before I proceed, notice I am using the word del to name the function delete. I am not calling it delete, because delete is an important reserved word in C++, and you use that to delete pointers and free up memory locations. So you're going to use the word del, but you can't just use the word delete for the delete function. So if you want to delete 10, the first thing you need a pointer, let's say by the name of current. So node pointer current. So you need a pointer by the name of current. So because you're beginning from the start, you're going to make current point to the start. Okay. So current has been assigned start. So current points to the first node. Now, if the value that current is pointing to happens to be the same that you want to delete, and that's how you're going to show it in coding, then you can actually do something about it. And it's not that hard. All you have to do is really, because it was pointing here, you need to make sure you're pointing to the node behind, next to it. So you're going to say start has been assigned starts next, okay? So start gets updated to the node that comes after the current node, so current's next. You could say start has been starts next, or you could say start has been assigned current's next. In either case, it will be updated to the node that comes after. And then you have to delete the current node, okay? So you can do that by calling out the delete current, right? It's because of this reserve word delete, you can't use the word delete for the delete function. And that's why I'm using del here. And obviously now that you've deleted a particular node, you have, and you can see here that your double linked list is now one node shorter. You need to update the length function, so its length has been assigned as length -1. Now, one last thing before you go, because this is the node, which is now the start node, this node's previous has to be null, okay? And that's what you're doing. You're saying starts previous has been assigned null, okay? Now, another case of the delete first node is you're trying to delete the first node and there is only one node, okay? Again, you can easily solve that. All you need is a node pointer current, which points to the start. And you can do that by this. You do really the same process. You update start. So start is current's next. So start gets updated to null. So start has been assigned current's next. You can also do that, but I would prefer that. And then you can just delete the current node. So this whole thing gets deleted. And obviously you're going to reduce the length by 1. This time you don't update starts previous as null because that's going to give you an error. So you just stop here. Okay? So that was case 2. So we've discussed case 1, which was the list is empty, and case 2, you're trying to delete the first node. Now let's discuss the third case, that you're trying to delete a node which falls in the middle. In this example, this has to be 20. So you're trying to delete 20. Okay? And you really start with the same way. You make a pointer by the name of current, which points to the beginning of the node, right? It points to start. And then you really run a while loop. So in the while loop, what you're doing, you continue to update current. You just say current next, current has been assigned as current's next, up until you reach, the end. Or the value of the current node is less than the value which is here. Now, this is interesting because notice my double linked list is actually sorted. So 10 comes first, then 20, and then 40. You can actually design your double linked list to be sorted using the add function. So if you're trying to add, let's say 30 doesn't get added after 40. You can design it in a way that it gets added in between 20 and 40. So it's always sorted. And that helps. That really helps. Because it helps in searching for a particular node if the list is pre-sorted, and it also really helps, you don't have to search the entire list every time you want to delete something. If you want to delete, let's say 30, and you reach 40 here, because 40 is larger than 30, you can just stop, because there is no need of going ahead, because you've already reached a value higher than that. That means 30 is not part of the list. Okay? So all you have to do is if either of these two conditions are true, they are met, you just update current, so it now points to the next node. That's how it happens. So when you reach, let's say, a node which is in the middle, which is the case shown here, you check the value. Is the value that the current pointing to the same as the one that you're trying to delete? If that is the case, well, that's good. So now, if that is the case, you really need not one this time, but two pointers. P, which is indicative of previous, and N, which is indicative of next. So what will happen is that you want P to point to current's previous node. Notice the current node is shown in red, and the pointer emanating from this node is shown in red. So the previous and the next pointers both are shown in red. So P therefore is assigned current's previous, and next N is shown as current's next. So then P and N are both pointing to this. So let's look at it in a little more diagrammatical way. So here P is shown in red and also the pointers associated with it. The whole node n is shown in blue along with the previous and the next associated with it, and current is shown in black along with the previous and the next associated with it. So what you really want to do is, when you want to delete this guy, all you want is you want previous is next to point to n, and you want next previous not to point to C but to point to P. Now just for now I want to remove this C. It's not removed, I just want to remove it diagrammatically so we can focus on something else. Okay, it's there, but I just want to remove it for now. So what you now want to do is you want to update this. So previous is next is not pointing to C anymore, it wants to point to N. And you can do that by this simple statement. Okay, and similarly next previous, which is shown blue here, you don't want it to point to C, you want to point it to P, and you can do that by this simple statement here. Now that this whole node has been, circumvented, so if you start from here, you're going to come here and then you're going to come here. If you start from the end, you reach here and then you reach the node previous to it. So you're kind of like bypassing this every time. So let's bring back our C. And now all you have to do, hence because it's not even showing in our traversals, you can just delete it. And you can delete it by saying just delete current, and whenever you delete it, obviously you need to reduce the length by 1 because the size of your double length link is 1 length shorter. Now we can represent this in a different way, much more pleasant way, which is this, getting rid of the current in the middle, and that's the whole code for your delete middle guy. Okay, so again, we've resolved 3 cases. There's still 2 cases left. What happens if you want to delete the last node, and what happens and what should you do if you're trying to delete something, it's not there? Well, to ensure that this lecture doesn't become too long, we're going to discuss cases 4 and 5 in the next lecture. Okay, so up until next time, thank you very much. Hope to see you next time. Bye-bye.